Yeah, so how many number will receive 0? How many of the number receive 0? Right, so those that will receive 0 cent, how many? Just 1 out of how many? 6, right? So that will give us 1 out of 6. About those that receive 30 cents. Those that will receive 30 cents, there's just 1 also out of how many? 6 also. There's just 1 out of 6. Right? And about those that will receive 60 cents. Those that receive 60 cents, and that is just how many? Also 1, if it's just 1 of the number out of how many? 6. Now we can bring out the expected value from this, right? We can think about the expected value from this variable that you're looking at right now. But before we bring out the expected value, we can sum up this value. We can go ahead and sum up this value. So if you go ahead and sum up this value, 3 over 6 plus 1, right? That's 3 plus 1 plus 1 plus 1. That will definitely give you 6 over 6. 6 over 6 is going to give you 1 if you want to sum up. If you're taking the sum there, the p probability distribution of that p of x, which here definitely that place here is this summation of the probability distribution, and it is going to be 1. That makes some sense. Okay, so how about the expected value? How about the expected value? The expected value in this concept here, the expected value, what you're expecting here out of this option here right now, which is what the expected value. And you guys know what the expected value is. That the expected value, I could put that here, which is also your weighted mean, equals x multiplied by the probability distribution of x. You have this and you have that. You might pause the video and think of what the expected value will be right now. So what do you guys think the expected value will be? Okay. All right. To get the expected value, this is pretty simple. Just follow the procedure, and that will be, in this case, you guess right, negative 40 multiplied by 3 over 6. Okay, so just going to keep the color straight, by 3 over 6. Okay, so and then the next one is going to be 0 multiplied by 1 over 6. Okay, and then the next one will be 30 multiplied by 1 over 6. And then the next one will be 60 multiplied by 1 over 6. Okay, so you can go ahead and sum up this variable, which is what I'm going to do here. Alright, I think we can do it here, directly under here right now. Okay, so the expected value now will now be equal to, that will be negative 120 divided by 6, right? So that's 40 times 3, that's negative 120 divided by 6, and that's plus 0 times 1 over 6, that will be 0 over 6. Okay, then plus 30 times 1, that's 30, that's 30 over 6, plus the next one, which is 60 times 1 over 6, and that's going to be 60 over 6. Okay, so you can take your expected value, as everything will be over 6, right? It will all be over 6, and then you get minus 120 plus 0 plus 30 plus 60. So we can take the expected value, and we'll get here, that will be 90, right? That will be about minus 120 plus 90. Everything will give us here minus 18, I guess 18.17 cents, right? That's what you're going to get off with, right? So that'll be minus 18.17 cents. Now we have other questions here. Let's get to it. We've done the A, and then we've done the B part. Now let's go to the C part of the question. What does the expected value represent? What the expected value represent is the mean. Did you forget? The average. Mean means average. The average, right? The average value, right? That will be n by whichever person we believe to play this game. So, which means the average value that whoever played this game is going to get is minus 18.17 cents. That is the average value a person will get for playing this game. So the expected value we obtain here is the mean, the average value that a person is expected to either win or lose. In this way, it's a loss. This game is a loss. Of course, the odds look like I'm going to win, is that not? But if you look at it vividly, right, you're not knowing that you're losing the game, so it's a lost game. You're losing. So, which means an average person, at every person that played this game, you're expected to lose 18.17 cents. You're paying 18.17 cents here at an average. So that is what that means. How much profit would the casino expect to make on 100 games? So on 100 games, since this is the average value, right? If I'm looking at, if this game is now played 100 times, if this game is played 100 times on 100 games, and we know that on average, this will be what each person will lose. So the casino should gain about negative 18.1, that's 18.17 times 100. That will be the gain that we are calculating for the person who owns the casino. Expected amount that we're thinking that you should get if this game is played 100 times by 100 people is expected to collect 18.17 from each of them, and that means he's going to get 100 multiplied by 18.17 cents is the amount he's going to gain in total from 100 games. Does this make sense? So that is that. So between the next video where I'll be explaining how I'll be talking about the some kind of formulas that have attribution to expected value, and some properties of expected value is what we'll be discussing in the next video. Please do well to share, subscribe, and like, and also click on the notification bell so that each time I drop a video like this, you'll be notified.